Welcome dear students. In this lecture we are going to talk about a very important reaction of the alkenes, and that is the ozonolysis of the alkenes. For ozonolysis, an alkene is placed in an inert solvent. This one is the inert solvent in which this alkene is present, and then ozone is bubbled through this mixture. When ozone is bubbled, then, dear students, an oxidative cleavage reaction starts. As a result of this oxidative cleavage reaction, the double bond between two carbon atoms is cleaved, and both sigma and pi bonds are broken down. When the sigma and pi both bonds are broken down, then the alkene is converted to the carbonyl compounds. And my dear students, these carbonyl compound that can be either some aldehyde or ketone or a mixture of both aldehydes and ketone. The nature of the products, it depends upon the structure of the alkene that is being ozonolyzed. So this is the introduction of the ozonolysis, in which an alkene in the inert solvent is present, and then ozone is bubbled. An oxidative cleavage reaction starts, which breaks both sigma and pi bond present between the carbon atoms, and the alkene is changed through a series of reactions to the carbonyl compound. This conversion of the alkene to the carbonyl compound with the help of ozone and reductive workup, that is called as the ozonolysis of the alkene. Now let us see some reactions, just like we have ethene. If ethene is first treated with ozone and then zinc dust and water, zinc dust means powdered zinc, then my dear students, the double bond gets cleaved, and both carbons which were joined by the double bonds, they will get one oxygen atom, and both will be oxidized. So the double bond will be broken down, and the carbon with double bond, they will get one oxygen atom each, and now we will get the carbonyl compound. And in this particular case, the ethene is basically changed to the two molecules of formaldehyde. Similarly, my dear students, if I will be having propene, and that will be first treated with ozone, and then for reductive workup it is treated with zinc dust and water. Again the double bond will get cleaved, and the carbon which were first joined by the double bond, they will get one oxygen atom each. So this one is acetaldehyde and this one is formaldehyde. In this case you will get a mixture of acetaldehyde and formaldehyde. My dear students, if we have one butene and that one butene is again treated with first of all ozone, and then it is treated with zinc dust and water. So the double bond will get cleaved, and the carbons which were joined by a double bond, they will get one oxygen atom. Now this one is an aldehyde with three carbon atoms, that is propanol. It's a IUPAC name, and it is formaldehyde, or in IUPAC language, it is called as methanol. But if we will be having 2-butene, listen very carefully. The same reaction will be performed, and my dear students, again the double bond will get cleaved, and the two carbon atoms which were joined through double bond, they will get one oxygen atom each, and you will get 2 moles of the ethanol or acetaldehyde. Now listen very carefully. 1-butene and 2-butene, these are position isomers of each other, and when they are ozonolized followed by the reductive workup, then my dear students, in these cases the different products are obtained. In case of 1-butene, mixture of propanol and methanol is created. In case of 2-butene, the two ethanol units are formed. It means that changing the location of the double bond in the alkene changes the nature of the products of the ozonolysis. This fact is very important to locate the position of the double bond in an alkene. So if the question is asked that the products are propanol and methanol, so what type of alkene is ozonolized? The answer will be 1-butene. But if after ozonolysis we get 2 moles of the ethanol, the alkene that is ozonolized will be 2-butene. So changing the position of the double bond changes the nature of the products of the ozonolysis, and this fact is used to locate the position of the double bond in alkenes. Now, my dear students, very important, what is the mechanism of the ozonolysis of alkene? Let us talk about the general mechanism. This one is the resonance form, one of the resonance structure of the ozone. When it is made to react with an alkene, then my dear students, this first step will be electrophilic addition reaction, in which this negative oxygen that will attack one carbon, and the pi electrons, they will attack on the lone pair of the other oxygen atom, and through the electrophilic addition reaction we will get a highly unstable intermediate product. Sorry, that intermediate product will be, first of all, a mole ozonide. It is highly unstable because of its unsymmetrical structure, as all oxygen atoms are present on one side of the molecule, and these two oxygens, they are highly electronegative. They will pull the electrons from carbon with a great force, and because of the pull of these two oxygen atoms, the carbon-carbon bond, that will be under a huge stress. This oxygen atom will attract electron from this carbon. This oxygen will attract electron from the other carbon, and the competition for the electron will start between the two carbon atoms, due to which this bond will be under huge stress. And that's why the mole ozonide is highly unstable and short-lived, and it is formed only for very, very small fraction of time. This mole ozonide is then converted to two intermediate products. Dear students, all oxygens in this mole ozonide, They are having two bonds, so they will be having two lone pair of the electrons. This carbon-carbon bond will be shifted between this carbon and oxygen, and there will be a double bond now. So you will get C. These two bonds are unspecified, and here a double bond will form. So first of all, you will get a carbonyl compound. And secondly, my dear students, now this bond that will be shifted here, and by using the lone pair of electrons, the oxygen will form bond with carbon atom, and another product will form that will be this one. It will be called as the carbonyl oxide. And this carbonyl oxide is again highly unstable, so they will get rearranged. As a result of rearrangement, this oxygen, because of its pi electron, will attack on this carbon. This double bond will be shifted here, and this oxygen, because of its negative charge, that will attack on the carbon atom. As a result, a highly explosive intermediate is formed, and this highly explosive intermediate, that is called as the ozonide. Because it is highly reactive and explosive, so it is not separated from the reaction mixer, rather within the reaction mixer, then the workup reaction starts. Now there are two options. The first option is that oxidative workup starts with H2O2. If the oxidative workup starts with H2O2, then my dear students, the resultant product, that will be the carboxylic acids. And what kind of carboxylic acids will be produced, that will depend on the structure of this alkene. But this is very rare because mostly the reductive workup is carried out, and for that reductive workup we use the solvent like water. And my dear students, now this compound will get cleaved. Oxygen that will be given to this carbon, and it will be changed to H2O2, and finally these two portions that are basically the two carbonyl compounds, and you will get the two carbonyl compounds. Now this H2O2 should be stabilized immediately. That's why the zinc dust is placed in the reaction mixer that reduces this H2O2 to water again, and thus the oxidation of these carbonyl compounds can be prevented. If this H2O2 is not stabilized by using the zinc dust, then these carbonyl compounds, they will be converted to the carboxylic acid through the oxidation. But my dear students, this is the oxidative workup which is very rarely carried out. But if oxidative workup will be carried out, you will get carboxylic acid, and this is reductive workup which is usually carried out, and you get the, or mostly the reductive workup is carried out, and you get the carbonyl compounds as the products. The workup is basically the manipulation of the steps which are involved in the separation and isolation of the pure product from the reaction mixer. So that is basically the workup. Now, my dear students, the last thing is that if an alkene is given, how can we judge its products? And if the products are given, how can we define the alkene? Suppose that we have acetaldehyde and acetone as product of the ozonolysis, and you are required to determine the alkene from which these two products are obtained after ozonolysis. Simply direct the oxygen of the carbonyl groups towards each other, and then remove both the oxygen atoms, and join the carbon through double bond. So this one will be the alkene, where that will produce acetone and acetaldehyde on ozonolysis. And that is, I think so, if the CH3 group is placed here. So you can simply define it as 2-methyl-2-butene. Similarly, if as a result of ozonolysis, two acetone molecules are obtained, you will again write down the acetone molecules in this fashion. You will remove the oxygen and you will join the carbons by double bond. And you will say that this is the 2,3-dimethyl-2-butene, which is basically ozonolized to get the two molecules of the acetone.